Here's our next lesson, class. It's 5.2. We're going to be simplifying polynomials. This video is on adding and subtracting polynomials. So for our first one, this one is written in function notation. I told you back in chapter 2 that when you see something in function notation, what you can almost kind of picture is you can picture a machine. This is called the f of x machine and the g of x machine. So we kind of talked about this in chapter 2, but if you put something into the machine, you're putting something into the variable. And then you want to see what comes out on the other side of the machine. So after we put something in for these variables, let's see what we get on the left side that comes out. So that's the whole rationale behind the function notation. These problems are really quite simple. Sometimes just the notation can really slip people up. So all we're saying is that if we're adding f of x plus g of x, we want to add what f of x equals, which is x squared minus x minus 2, plus whatever g of x equals, which is x minus 3. So f of x, this machine, plus this g of x machine, is going to equal the sum of x squared minus an x minus 2 plus x minus 3. So now, as you guys learned this back when you were first working with monomials, you learned to combine using like terms. So x squareds can only be combined with other x squareds. So I have an x squared right here, and that's the only one that I have, so I bring down the x squared. I like to cancel these off sometimes after I use them, just so I know that I don't have to use it anymore. I have a negative x plus an x, making 0 x's. I don't even have to write that down. They are gone. And then I have a negative 2 minus 3, making a negative 5. So if I add f of x plus g of x, my sum is going to be x squared minus 5. Not too bad, I don't think. On the next one. This one is not written in function notation. I just do what's written. However, this is a difference, which means I have to distribute that negative sign. So it's kind of like saying a negative 1 right here. So what I like to do is I'm just going to get rid of these parentheses by saying 3x squared minus 2x plus 3. I distribute the negative, so it's a negative 1 times x squared, which is a negative x squared. A negative 1 times 4x, which is a negative 4x. And a negative 1 times a negative 2, a negative times a negative is a positive. And now that I just have adding, all I'm going to do is I'm just going to combine like terms. So I have 3x squared minus 1x squared is 2x squared. Those are gone. I have a negative 2x minus 4x. A negative 2 minus 4 is a negative 6x. That takes care of my x terms. And then I have a positive 3 plus 2, making it a positive 5. So my answer, when I subtract 3x squared minus 2x plus 3 minus x squared plus 4x minus 2, is 2x squared minus 6x plus 5. Last one on adding and subtracting. This one I have both of them. Really the process remains the same. All I do is I distribute this negative sign right here, and then I just add from left to right. So I have 3x cubed plus 5 minus 3x squared minus 3 plus 8x cubed minus an x squared. So all I've done to go from this line to this line is just distributed this negative 1. And now I combine like terms. So I always start with my highest degree. I like to write my polynomials in descending order, and you guys should feel comfortable doing that as well. Start with your x cubed terms. So you have 3x cubes and 8x cubes, making 11x cubed. Takes care of those two. Next would be my x squared term. I have a negative 3x squared and a negative x squared, making a negative 4x squared. That takes care of this one, and that takes care of this one. I next go on to my x terms, or x raised to the first, and as you can see, I don't have any x raised to the firsts. So I'm not even going to write that down. And then my last term is my constant term, which is a positive 5 minus 3, making a positive 2. My answer, 11x cubed minus 4x squared plus 2. And that concludes this very, very short lesson on adding and subtracting polynomials.